Hello, this one is lesson 1.2, and we are going to be going over absolute value functions. So we're going to be graphing them, identifying properties of the function, and then also writing an equation. Our first one, we have our vocabulary, vertex. So for our vertex in this lesson, we are going to be using the definition, a point that is the maximum or a minimum. So our vertex is either going to be the highest point on our graph or the lowest point on our graph. Next, we have the word absolute value equation. And the absolute value equation is going to be a V-shaped graph that opens, oh, I do not know what I'm writing there, sorry. That opens up or down. Our absolute value function does have a standard setup that we are going to use every single time. And that setup is going to be y equals a, and then the absolute value symbol is these two lines. And inside the absolute value sign, we are going to have x minus h. Then outside of the absolute value, we are going to have plus k. Now, the variables in here, a, h, and k, are going to tell us a lot of information about our graph. The first thing that we are going to look at is the a value. Actually, sorry, I lied. We're going to look at the sign in front of the a value. So the sign in front, if it is positive, that tells us our graph is going to open up. So it's going to be a regular V shape. If it is negative, that means a is going to be obviously negative, it's going to open down. So the sign in front is going to tell us if it opens up or down. Then the a value itself is going to tell us a little bit of information as well. For this one, if just the number, ignoring the sign, if a is greater than 1, we are going to have a narrower graph. If a is less than 1, so it's like a fraction or a decimal, like 1/2 or 0.5, we are going to have a wider graph. Then if a is equal to 1, we're going to have a standard size graph, and we're going to compare it to the function f of x equals the absolute value of x. And when we compare it, if a is equal to 1, it's going to be the same. And again, when we are identifying if it's narrower, wider, or the same, we are ignoring the sign in front. The sign in front is just telling us if it opens up or down. Then the last piece of information that you need to know from the equation is that h and k are going to tell us the coordinate point for the vertex. So our vertex is at the point h comma k. What you need to make sure you pay close attention to is when h is pulled out of the equation, h is going to be the opposite sign. When k is pulled out of the equation to get our coordinate point, this one is the same sign. H is opposite, k is the same. All right, once you have that copied down, now we are going to look at an example. So for example 1, we're going to graph the equation y equals 2 times the absolute value of x plus 1 minus 2. And with this one, we are going to answer the questions A through F before graphing. The reason we are going to do that is because sometimes you'll be asked to answer these questions without having to graph the equation or without having space to graph it. So you need to know how to answer them without depending on that graph. So let's start with our vertex. Our vertex is that h and that k value. And remember, h is the opposite sign. In our equation, h is a positive 1. So in the vertex, h is going to be negative 1. K stays the same, so that will also be negative 2. Slope. Now, this might not be asked on a quiz or a test for the slope, but I want you to identify which number is going to give us the slope of part of our graph. And that is our a value. So our slope in this one is going to be 2 or 2 over 1. So that tells us when we are graphing part of our graph, we're going to be going up 2 and right 1. And this slope is going to be for the right side of the graph. So when we do the right side of the graph, we are going to use that a value as our slope. And this is including the sign. Okay, next, does it open up or down? This one, a is positive, so it will open up. Then, is it narrower, wider, or the same as f of x? And if we look back at our notes, if a is greater than 1, it's going to be narrower. And in this case, a is in fact greater than 1. So narrower would be our answer. Okay. Next, we have domain and range. Remember, domain is associated with all of our x values. And in this case, we are going to have a V-shaped graph that is going to continue on forever in both directions. So it's going to continue to get wider, meaning we are going to cover every single x value. That is going to happen for all absolute value graphs. So our domain is going to be all real numbers every single time we have an absolute value graph. So you can go ahead and write all real numbers for that. Next, we have to identify our range. Now remember, range is talking about what y values we have. And I know I told you to answer this before graphing, but we're going to graph just the vertex so I can give you a visual of what I am talking about with this. So our vertex is at -1, -2. And we said that our graph was opening up. So that means our graph, the lowest point, is going to be at y equals -2. So because our graph opens up, we are going to be covering all of the y values that are -2 and higher. That means when we write our range, which is talking about our y values, we are going to write y is greater than -2. If our graph had opened down, then instead of all these greater than values, we would be looking at the less than values or the smaller values. And the only thing that would change would be our inequality sign. But for this equation, because it's opening up and a is positive, we're going to write y is greater than. So we are talking about all of those y values. Okay. Now that we've gone through all of these questions, we're going to go ahead and graph our equation. So remember I said this is going to be a V shape. And when you are graphing an absolute value function, it will be symmetrical, which means that every point that we graph on the right side, we can graph that same point on the left side the same distance away. And this is where our slope is going to come in. So remember I said that this is the slope of the right side of our equation, or the right side of our graph. So on the right side, we're going to have a slope of 2. So we're going to go from our vertex up to right 1, up to right 1. And that pattern will continue. That is half of our graph. Now it is symmetrical, so we're going to look at how far away each of these points are on the right side and put a reflection of that on the left side. So this first point was 1 space away from that line, so I'm going to go 1 on the other side, and that's where I got that first purple dot. Now my second point I did on the right side was 2 away from that line, so I'm going to go 2 in the other direction to put another point there. Now the third dot was 3 away from the line, so I'm going to go 3 on the opposite side, the left side, and that will give me the V shape that I need for my absolute value graph. So go ahead and make sure you have this down on your notes. And that is one example. If you would like to pause it here, I would like you to try example 2 on your own and see what you come up with, and then you can check your answers. Okay, so hopefully you have your answers so far. Again, we're going to answer the questions on the left before we graph it. For our vertex, we need h and k. Remember, h was the opposite, so it should have been -1 for your vertex. Next, we are going to look at the slope. And again, it's just the slope of the right side of our equation. And the slope is our a value, so -2/3. So on the right side, we're going to go down to right 3. This one, our a value was negative, so that means it's opening down. Then when we identify if it's narrower, wider, or the same, we're looking at just the number. So just the 2/3. And because 2/3 is less than 1, that means it's going to end up being a wider graph. The domain was the same for all of our graphs, which is all real numbers. And then our range. So if we think our vertex, our y value, because range is talking about our y value, starts at -1, and our graph opens down. So because it's opening down, that y value of -1 is going to be the highest point or the maximum of our graph. And all of the y values are going to be less than or smaller than -1. So when we write our range, we can write y is less than -1. Oh, I am so sorry. I forgot. Make sure the vertex is part of the graph. So we need to make sure we also include the or equal to. Sorry about that. So with these, the vertex is part of the graph. So we have to put the or equal to, because that vertex will be on the line of the graph. So it will be equal to that. Okay, now that we have that covered, we can go ahead and graph our absolute value function. So our vertex was at -1, -1. The slope on the right side was -2/3, so down to right 3, down to right 3. And I'm just going to graph 2 extra points on that side. Now that I have that side graphed, if it's helpful, you can draw that line of symmetry so you can reflect the points over to the other side. So the first one was 3 away. So I'm going to go 3 to the left of the line. The second one was 6 away, so I'm going to go 6 away on the left side. And that gives us our absolute value function. When you graph it, it should be a V. There are no curves on these graphs. Okay. Now that we know how to graph them, we're going to go back and write some equations. Okay. So if we look at this graph, for example, 3, this one, if we check that all the points are symmetrical on each side, is an absolute value graph. But if we read the directions, they want us to write a piecewise equation. The nice thing about this is that we are going to write it in the same setup or form that we are going to write the absolute value ones. So we're going to start with our equation here. With a piecewise one, we write f of x, and we have 2 equations. We also have the 2 inequalities. So let's start with the inequalities first. So the first one can be the right side of our equation, and that starts at the x value of 2. So, and it's going to the right. So that means x is going to be greater than 2. Then the second part on the left side, that is going to all the values that are less than 2. So in this one, x is less than 2. Because it's a piecewise graph and that vertex is included in the graph, one of these inequalities needs to have the or equal to. It could be the top one or it could be the bottom, but only one of them should have that or equal to. Once we have that, we can go ahead and write our equation. On the top one, we're going to write our negative slope. On the bottom, we're going to make it a positive slope. That's the only thing that's going to change between these as a piecewise graph. So to write our equation, we need to find our a value, or the slope. So we're starting with the negative one, which was on the right side. This one goes down 2 and right 3. So we have a slope of -2/3. Instead of absolute value signs, we are going to use parentheses. With the parentheses, we need to know what our h and our k values are. So h was 2, and remember in the equation it's the opposite sign. So instead of positive 2, we'll do minus 2. And then k goes outside of the parentheses, and that would be plus 1. Now, because this is a piecewise graph, we then need the equation of the other side of our graph. And the only thing we need to change is instead of a negative slope, we are now going to have a positive slope. Everything else of that equation stays the exact same. Nothing else changes. Okay, then we're going to answer our domain and range. Just like before, the domain is all real numbers. And our range, if we look, remember range is our y values. So our y starts at 1 and then goes down. So that means our range, y, is going to be less than or equal to 1. Okay, that was example 3. Now if we look at example 4, you'll notice the graph is the exact same. The only thing that changed was we need to write the equation using absolute value function notation. So make sure you're reading the directions on the test or quiz so that you know what way you are going to write it. So because this is an absolute value function, we're going to write it as y equals. We already know what our a value was. It was 2 over 3. And because our graph is opening down, it has to be the negative 2 over 3. Then our absolute value symbols. Inside the absolute value, we have x and our h value. And remember, h is always the opposite of what it was in the vertex. In this one, h is a positive 2. In the equation, that means we're going to do minus 2. K goes outside of the absolute value sign and is the same. So we'll put a plus 1 at the end of our graph. Now, since the graphs were the same, the domain and the range are going to be the same for this answer as well. So that's how you would write the equation as a piecewise graph or an absolute value function. You just need to make sure you read directions to see which one you need to do. Okay, once you are done with that, you should try example 5 and then check your answer once you have it complete. All right, reading the directions, this one is an absolute value function. So I'm going to start with y equals, and you don't want to forget that absolute value symbol there. Okay, the number in front, it is opening up, so I know it is positive. Then I need to find the slope. I'm going to find the slope on the right side of my equation, so I need 2 points. And if I look, this one's going up 2 and right 1. So my slope or my a value is just going to be positive 2. The vertex was at 2, negative 2, and remember, the first number is your h value, and the second one is your k. When you plug h into the equation, it should have been the opposite sign, so x minus 2 in the absolute value symbols, and then our k goes after it with a minus 2. Lots of 2's in this equation. Then we need to find our domain and range. Our domain is the same as all the other absolute values, all real numbers. Our range is, again, the y value. So if we look at the y of our vertex, it starts at negative 2. And this graph is opening up. So it's covering all of the y values that are greater than negative 2. So when we write y is greater than negative 2. And don't forget that or equal to. I know I almost forgot it on the first page. So make sure you are including that in your answers. If you have any questions on this section, make sure you are reaching out and I can get back to you as soon as possible. Have a good day.